Very good morning, children. In the previous class, we discussed about the molarity, molality, mass percent, and mole fraction. Previous class ಅಲ್ಲಿ ಇದೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಮೊಲಾರಿಟಿ ಅಂದ್ರೆ ಏನು, ಮೊಲಾಲಿಟಿ ಅಂದ್ರೆ ಏನು, ಮಾಸ್ ಪರ್ಸೆಂಟೇಜ್ ಮತ್ತೆ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಸ್ಟಡಿ ಮಾಡಿ. ಅದರ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂತ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. The problems regarding the molarity will first we will discuss. That is two problems has written on the board. That is the first problem. We'll check it out. The first problem. That is calculate the molarity of NaOH. Now, what ಮಾಡಬೇಕು? Calculate ಮಾಡಬೇಕು. ಯಾವುದು? Molarity of the NaOH in the solution prepared by dissolving its 4 gram in enough water to form a 250 ml of solution. Form a 250 ml of solution. Here, what they are given in the data? The mass of the solute they are given. Then, volume of the solution given. Then, we should find the molarity. Means, these two factors is enough? No. Here, factor is the sakagala. Adu jotege namage molar mass of the solute also required to find the molarity of the solution. The first, what the mass of the solute? How much they are given? That is the mass of the solute. That formula we are going to represent by WB. That how much they are given? That is 4 grams. That given that 4 grams. Then molar mass of NaOH. Molar mass of NaOH. For this, we should calculate the molar mass. That is the molar mass of the NaOH. That is number of sodium atoms in the NaOH is 1. That is 1 into 23 plus number of oxygen atom is 1. That is 1 into 16. Then plus number of hydrogen atoms is 1. That is 1 into 1. We know that how to find the molar mass. Already in the previous classes we discussed that. Here the 23. 1 into 23 plus 16 plus 1. We are going to begin that 40. That is the unit used for the molar mass is gram per mole. This is about the gram per mole. Then the next volume of the solution. How much they are given? The volume of the solution. How much they are given? That is 250 ml. 250 ml. This is about the volume of the solution. The formula which is used to find the molarity is equal to that is WB divided by MB into 1000 divided by that is the volume. Means here WB is nothing but mass of the solute. MB is nothing but molar mass of NaOH. That is molar mass of the solute into 1000 divided by B. B is nothing but volume of the solution. Now substitute the values. That is mass of the solute is 4 gram. Then molar mass is 40 gram per mole into 1000 divided by the volume of the solution is 250. Then you are going to be get that is 0. On calculating this, we are going to be get that 0.4 molar. That is molarity. That is molarity of the given NaOH solution is 0.4. This is your answer. Okay, understood? Like this only, we should solve the next problem also. We should find the molarity. Means in this second problem, what they are given? They are given that the calculate the molarity of sucrose in mole per liter. If 10 gram of sucrose is dissolved in enough water to make a final volume of 500 ml. In this also same procedure, that where they are given the mass of the salt group, you should find the molar mass of the sucrose, and you should write that the volume of the solution they are given. Then you should find the molarity. First we will write that in that what they are given, mass of solute, that is WB is equal to how much they are given? 10 gram. They are given that 10 gram. Then molar mass of sucrose. Molar mass of sucrose. Molar mass of sucrose means you should know the molecular formula. What is the molecular formula for sucrose? That is C12, H22O11. This is about the molecular formula of the sucrose. Now we are going to find this molar mass of the sucrose. How many carbon atoms? 12. 12 into 12 plus number of hydrogen atoms is 22. That is 22 into 1 plus number of oxygen atoms is 11. 11 into 16. On calculating this, we are going to get the 342. That is the molar mass of the sucrose. We are going to get that 342 gram per mole. This is gram per mole. This is about the molar mass of the sucrose. Then volume of this solution, sucrose solution, is given by the 500 ml. That is the volume of the solution is equal to 500 ml. That is here. Now we should find the molarity of the sucrose solution. The formula which is used to find the molarity of the solution is, that is molarity is equal to WB divided by MB into 1000 divided by V. How much WB? 10 gram. Molarity is 3 molar mass of the sucrose is 342 into 1000 divided by 500. On calculating this, we are going to get the value, that is 0.0584 molarity. This is about the solving of this problem. Once again I will explain. Calculate the molarity of the sucrose in mole per liter. If 10 gram of sucrose is dissolved in enough water to make a final volume of, that is 500 ml. The mass of the solute is equal to 10 gram. Then molar mass of the sucrose is equal to, that we should find, that is number of carbon atoms is 12 into atomic mass of the carbon plus number of carbon atoms into atomic mass of the carbon plus number of hydrogen atoms into atomic mass of the hydrogen plus number of oxygen atoms into atomic mass of the oxygen. On calculating this, we are going to get that 342. We are going to get that. Then the volume of the solution, they are given that 500 ml. Then molarity is equal to WB divided by MB into 1000 divided by V. Therefore, is equal to, that is mass of the solute is equal to 10. Then molar mass of the solute is 342 into 1000 divided by 500. On calculating this, we are going to get that 0.0 is 0.0584 molar. That is, molar is nothing but mole per liter only. That you can write this also unit if you have made, that is mole per liter. This is about the problems based on the molarity. Now we will discuss about the problems based on the molality. Now we will solve the problems based on the molality. That is problems, two problems are written on the board. That is calculate the molality of a solution when 1.5 moles of is added to 675 ml of solvent. Assume the density of the solvent is 1 gram per mole. What are they given? They are given the volume diagram. Volume of the solvent diagram, that is 675 ml. Then the density is there given, that is 1 gram per ml. Then number of moles they are given. Then we should calculate the molality. We know that the formula which is used to find the density they are given, volume they are given. Then we can find the mass by using the density formula. That is density is equal to mass by 1. We know this formula. In this formula, density we know, volume we know. Then we can calculate the mass of the solvent. That is mass is equal to density into volume. Therefore, the density how much? 1 into 675 ml. Then we are going to be get that 675 grams. The mass of the solvent we are going to be get that 675 grams. Then the formula which is used to find the molality is equal to the mass of number of moles of solute, into 1000 divided by mass of solvent in grams. They are given number of moles. How much they are given? 1.5 moles of solute they are given. That is 1.5 into 1000 divided by the mass of the solvent, that is 675. On calculating this, you can use a simple calculator. On calculating this, we are going to be get that 2.22 molality, small m. Here we are going to use that small m for the molality. This about the answer. We are going to get that 2.22 molality of the solution. Now we will solve the next problem. Next problem is a little bit different. We should find the molality only, but in a different manner than given. Density of 3 molar solution. 3 molar they are given. That is a molarity they are given. 3 molarity of the solution of NaCl is 1.25 gram per ml. Calculate the molality of the solution. For that given, that is sodium chloride. First, we should find the molar mass of NaCl, molar mass of the sodium chloride. That is molar mass of sodium chloride, molar mass of NaCl, that is sodium chloride. How much? That is the number of atoms in the sodium chloride. Sodium atoms in the sodium chloride is 1. The 1 into 23 plus number of chloride atoms is 1. 1 into 35.5. We are going to be get that 23 plus 35.5. We are going to be get that 58.5 gram per mole. We are going to get that the molar mass of the sodium chloride. We got that is the 58.5 gram per mole. Then we should calculate the mass of the solute. The mass of the solute equal to calculate. We know the formula, that is moles derived. That is moles derived. Moles is equal to, that is mass of the solute, then mass divided by molar mass. Molar mass. Then we should find the mass. Number of moles, what is given? 3 molar. Means it indicates 3 molar. Indicates that. If you want, you can write that. 3 molar means 3 moles of solute dissolved in 1000 ml of water. 1000 ml of water. This we call as 3 molar. That is number of, we need to calculate the mass of the solute. Then mass of solute is equal to, then moles into molar mass. Molar mass. How much number of moles? How much? 3 moles. 3 into molar mass of NaCl is, that is 58.5. Then on calculating this, we are going to be get that is 175.5 gram. 175.5 gram. We want that the mass of the solute. Then we should find that the density. Density they are given mass by volume. We know the formula, that is the density. Density is equal to mass by volume. Mass by volume. Now we should calculate the volume. We know the mass, then we know the density. Then we should calculate the volume. Then the mass of the solution is equal to, mass of the solution is equal to density into volume. Then mass of the solution is equal to density into volume. Density into volume. Volume how much? That is 1000. Then density is equal to 1. That is density is equal to mass by volume. We know that the density and the volume, we can find the mass of the solution. Mass of the solution is equal to density into volume. That is we are going to get that density is 1.25 into 1000. We are going to be get that 1250. That is about the mass of the solution. The mass of the solution. Then we know the mass of the solution now. Then we can find the mass of the solvent. The mass of the solvent is equal to, mass of solvent is equal to mass of solution, mass of the solution minus mass of solute. Mass of the solute. How much the mass of the solution? We got the 1250 minus mass of the solute is, that is 175.5. Then we are going to be get that the mass of the, that is the mass of the solvent, we are going to get that 1074. That is 1074.5. That is about the mass of the solvent we are going to be get that. Then now you can use the molarity formula by this using the molarity formula. That is molarity is equal to, that is the mass of the solute, that is W B. Then molar mass of the solute MB divided by into 1000 divided by the mass of solvent. mass of solvent. Then W means mass of the solute. How much we are going to get that? 175.5. 175.5. Then molar mass is, that is 58.5 into 1000 divided by mass of the solvent is 1074.5. On calculating this, we are going to get that is 2.79 molar. That is molarity. We are going to get that 2.79 molar. This is about the calculation of the molarity. That is the density they are given. We should calculate the molar mass first. We should calculate the molar mass. Then we should calculate the mass of the solute. Then the mass of the solution we should calculate, and the mass of the solvent again we will calculate. Then we will get the molarity. Molarity we can calculate the molarity of the solution. This about the problems based on the molarity.